from Cartesian product of two sets. Then we came to relations. From relations we have come to functions, and then types of functions. In this type of functions we will have two different types, okay, namely two different types. The first one is injective function and the second one is surjective functions. Let us go through the definition first, then we will understand what it means. A function f is such that from x to y, say I am taking a set x and it is going to set y. X set has x1, x2 up to xn elements. Y set has y1, y2 up to yn elements. Okay. A function f from x to y. So there is a function. Function is a bridge which links x and y. Is defined as 1, 1. These functions will be 1, 1 or injective if the images of the distinct elements x1's image will be y1, or I can write f of x1. x2's image will be y2 or f of x2. Distinct images of x under f are distinct. Suppose if it so happens that I have taken x1 and x2, okay, and say what has happened is this f of x1 and f of x2 give the same value. Say if it gives the same value p, suppose. So if f of x1 equals to f of x2 and it is equal to p, which I have given right now, and what happens is this is many to one, many to one function. But if I want to prove this many to one as 1, 1, then obviously this x1 should be equal to x2. If these two will be same, then one element is making one image. That means x is making p as the image. So that's why the concept is, if you want to check any function as injective or say 1, 1, then what you do is, for some x1, x2 belonging to the domain set, that is x, if by putting x1 and x2 in that function, f of x1 is equal to f of x2, simplify and you get x1 equals to x2, then it is clear that the function is 1, 1 unless many 1. Now the second type of function is, this is the first type, and the second type is a function f from x to y is said to be onto or surjective. Okay, it is surjective if every element of y is the image of some element of x under f. Every element of y, this is set y, all the elements of set y are the images of some element in the domain set x. That means what? This codomain will be a set consisting of only range. The meaning of this is, if codomain equals to range, the set of codomain and range is equal, then f is onto. Okay, if in case if it so happens that there lies one, say, image, say the image is f of k is the image, and this f of k do not have its pre-image here, then we will say that this function is into, into, into. What kind of function is this? Into, into function. Okay, if all the elements have its pre-image, onto is also called surjective. If there be one, at least one, there should be at least one, can be more than one, but at least one image whose pre-image is not there in the domain set, that means this function is into function. Moreover, if in a function you can prove that the function is 1 1 and onto both, then the function is called bijective. Bijective. Mark the word bijective. Okay. Bijective is injective plus surjective equals to bijective. So injective function, that is 1 1 function, plus surjective function, that is onto function. If we have 1 1 function and onto function in a particular one, we call the function as bijective function. And we are looking for bijective functions only because bijective functions are invertible. Okay, which I am going to discuss about it in my next class. I would rather conclude today's class, okay, that is day 3, with one more example. The example is, suppose I have to prove 1 1. You can see this NCRT book exercise 1.2, where they have given check the injectivity and surjectivity of the following functions. F is such that natural number to natural number. It is question number 2. One was very easy, that's why I did not go for it. Once you understand question number 2, you can easily solve 1 2 3 4 5. Okay. F is such that it is n to n given by f of x equals to x square. Check whether this is injective and surjective. They are not saying prove, they are asking you check whether it shows injectivity and surjectivity. So what will happen is, I have to borrow x1 x2 from natural number, that is domain set. And if f of x1 equals to f of x2, then x1 equals to x2, it is injective. I want to start with this. Say x1 x2 belongs to natural numbers, okay, domain set. If f of x1 equals to f of x2, we write like this. So f of x1 means x1 square equals to x2 square. Many of my great students, what they do is they cancel the square and they say x1 equals to x2, f is 1 1. Please do not do like this. What you need to do is x1 square minus x2 square, very easy, equals to 0. x1 plus x2 or x1 minus x2 equal to 0. Either x1 minus x2 equal to 0, x1 equals to x2, f is 1 1, or we cannot neglect the second part, x1 plus x2 equal to 0, x1 equals to minus x2. This gives me a hint that it is not 1 1. Okay, this gives me a hint that it is not 1 1 if I put a positive number. If one side is positive, the other side is negative. But I am restricted from natural number to natural number. So that is why I cannot go to negative numbers. So x1 equals to minus x2 is neglected, because there is no room that x2 or x1 can be negative. x1 x2 belongs to n. So therefore we can write f is 1 1 function, and it is injective. Is it onto? Is this function onto? Then what we do is, we just have to write very simple. See, instead of f of x, we write y equals to x square. Check onto. Okay, f of x, y equals to x square. Instead of f of x, I have written y. So I can even write x equals to root y. and your x belongs to natural numbers and y also belongs to natural numbers, say y equals to 2. I'm taking one natural number y as 2. Then y is the image as 2. I need its pre-image. So then x equals to root over 2. Root over 2 is the pre-image of the image 2, which perhaps do not belong to our set of natural numbers. I am restricted to 1, 2, 3, 4 up to infinity. So I have an image 2 whose pre-image is not there. That is why f is into function. I've said into function and onto function. It is not onto. You'll write it is not onto onto function. So what function it is? It is into function. Now the question number 2 has so many parts. When it starts with n to n, I'm checking this way. If I go for the same question z to z, okay, I'll just make few changes only. Z to z. Z means integers to integers. Then obviously x1, x2 belongs to n, f of x1 equals to f of x2. This is all same. Now this is also possible. The second case is also possible. Then what? Then I have a problem. The problem is -1 and 1. I can write this way. F of x1 equals to f of x2. I'm saying that x1 equals to x2 or x1 equals to minus x2. Two things cannot be possible at a time. So any value integer, that is x1, cannot be equal to its negative value, that is x2. So what we do is we just quote an example to prove that it is not 1 1. So what example do we put for this? So think of f of -1 equals to f of 1. Very simple. -1 ka square is 1, plus 1 ka square is also 1. So but input is different, not equal to 1. F is not 1 1. F is not injective because input is same, but the input is different but output is same. That's why it is many 1. And if I have to check for onto, goes the same way. I can even give one more example as say x equals to root y. I have the option of y equals to -2, x equals to -2 ka root over, and you can understand it goes to complex which do not belong to z and it do not belong to z, and since it is not surjective, it is not onto, again it is into function. So in this way, if again I just want to change once again, check from R to R. Now see, R to R. Okay, same question, f of x equals to x square. I started with n to n, z to z, and now R to R. R is real numbers to real numbers. I'm thinking of two values again, -1 and 1. They both belong to real numbers, and -1 is not equal to 1. F is not 1 1. Same answer you can paste. For onto, okay, what you have to do is y equals to x square, y equals to x square, x equals to root y. I was taking this example, only take negative number. If I take y as -2, x equals to root over -2, root over -2 is complex number. It do not belong to reals, so not surjective. So students, today we had a long video, not a problem. Please practice 1 and onto questions from exercise 1.2. One more thing which I want to clarify to everyone, I'm receiving so many like messages in WhatsApp and then initially it was okay, few messages, now it's coming in bulk. So I request you all to follow the school website where our link is been given for mail. You can send your doubts through mail following school website. Thank you. Bye.